Hello everyone, and welcome to the 3DV channel. My name is Sergey, and I'm the product owner of Face SDK. For over 10 years, our SDK provides customers with access to comprehensive face recognition technologies that you can natively integrate to your application, and it will work almost anywhere. Uh, we actively support 9 language APIs, and Uh, our ADKs works on regular desktops, both Linux and Windows, smartphones, specialized GPU servers, embedded solutions, and basically anywhere else. And now I would like to talk about the latest updates to our libraries. This summer has been very productive for us, and we have released 2 new SDKs versions. Let's take a look at the new features available for Face SDK users. Uh, and the first one is liveness detection improvement. As you may know, liveness check is a very important and often essential part of the face recognition pipeline. This technology allows us to protect against people who try to hide their identity or try to pretend to be someone else using some attacks like photos or digital screens or 2D and 3D masks and some more and more uh, attack types. At FreeDV, we are constantly improving and tuning our liveness detection technologies. Uh, you may check our documentation and see that we provide a wide range of liveness detection modification varying in performance and accuracy, so you can choose exactly what you need in your specific business case. And this summer, we have launched a new version of our liveness detection technology where we improved our 2D and 2D ensemble modifications, which now make about 3 times fewer errors when detecting attacks of different types. Um, the second global feature is deepfake estimator. Uh, in recent years, in addition to classic liveness attacks, deepfake-based face swap attacks have become an increasing problem for the use of facial recognition technology. Um, let's look at an example of how it works. Here you can see my photo, and here is a photo of Sid Meier, famous video game designer who created famous Sid Meier's Civilization game. Uh, so I've used one of publicly available face swap sites and get this wonderful fake. And the problem is made worse by the fact that the neural networks that um, used for deepfake have much the same theoretical base as the neural networks used for recognition. Uh, Therefore, uh, as you can see, generated photo uh, easily matched with target photo of Sid Meier. And here in 3DV, we we are aware of this problem, and that's why we released our first deepfake estimator model in Face SDK 3.27. Um, Let me demonstrate how it works. in some practice way. Uh, so here's just basic Linux terminal, and I'm in uh, Face SDK directory. Uh, so I want to use one of our C++ pre-built samples, which called processing block demo, and uh, I need just uh, specify some arguments like unit type and specify like fake deepfake detector, and I also need just to specify a path to image which I want to estimate is it deepfake or not. Uh, 1 second, and here we go. So in this sample, we use our deepfake estimator to define if this generated photo is deepfake or is it real. As you can see, yes, this photo is deepfake with pretty high confidence around uh, 0.7. So next global Face SDK feature is accelerated inference. Um, for the most part, all of our SDK models, I mean, face detectors, face recognition models, the previously mentioned deepfake and liveness, all of them are neural networks. In production, we obviously want them to work as fast as possible, which means we want to speed up their inference. Therefore, we have added support for two specialized inference engines to Face SDK. First of them is TensorT. It's inference framework from NVIDIA, and it's just the ultimate approach to get maximum inference speed for a specific neural network on a specific NVIDIA GPU. Second one is OpenVINA. Uh, it's inference framework from Intel that allows to accelerate inference on, at first, Intel CPUs. However, unlike TensorT, uh, there are several important nuances. Uh, to get a really cool boost in computing speed, your CPU needs to support some specific CPU instructions like AVX 512 and VNNI. So just follow our documentation to test new inference frameworks. Best of all, if you already have code that uses Face SDK processing blocks, you will only need to make some minor changes, just literally adding one line when you create each model, and you will get accelerated inference. It's just very, very minor changes. Okay. Also, this summer, we've added support for new language APIs to Face SDK. At first, there is a new Python API. There is not much to say about it. It's not so different from our old classic Python API, but now you can use it with latest versions of Python in no GIL mode. Finally, Python developers who use the Face SDK will be able to truly parallelize their face recognition pipelines. In addition, we have added two brand new APIs, currently only for Linux, but just at the moment. And the first one is Node.js API. This means that you can natively integrate face recognition pipelines into your server-side JS application. And let me show you how easily you can start with Node.js API using 3DV Face SDK. So we return to our Linux terminal, and when we when we've installed Face SDK on our computer, we need to also install npm package. To do that, we need just one command, npm install, uh, and we need to specify directory where npm package is located. In our case, it's just Node.js API. Uh, yes, as I've already installed to my PC, it was pretty fast. And now we can just go to our examples and just run some of the samples we have for Node.js. Uh, so, for example, uh, we can use quite the same demo we used previously, uh, but now in Node.js, and we can make deepfake estimation of our deepfake generated file, just like that, and it prints us some time. As you can see, we have here in pipeline face detector, which work for around 14 milliseconds, and the deepfake estimator itself, which works for around 150 milliseconds, and it works the same way. It give us same result as before. So we have much more Node.js example in our base Face SDK distribution. You can hear some examples which um, allows you to try out detectors and filters models. There are also all needful source code. Of course, there is a sample for face recognition here, and also our documentation full of Node.js snippets too. Okay, and now we move on to the last item on our list of summer features. It's Go API. Now you can develop fast and scalable backends using Face SDK. And let's also mm, take a look how easily, in fact, you can start and run some sample uh, of Go API with face recognition. So basically, at first I need to have valid Go in my console. I don't have it, so I need just to make some magic, and yeah, Go is here. So after that, we go to Go examples folder, and here we have special microservice sample. Um, mm, and here we need just to specify run a search script, which starts our microservice application. And okay, let's try it. Yeah, we also need to specify images path argument. Um, uh, Argument, which is in our case should be uh, yes, it should be here. So it's just path to folder with some images of some persons, and this sample use them to generate a database of templates. And also when we start script, we have some working server, a local host. Uh, it's pretty basic HTTP page, which just show us total possible size of database. In this case, it's 1,000 face templates, and how many face templates in database we have at the moment. In this case, it's just two. Uh, so this is just some main page which we use, which we get using uh, get request, but there are also uh, um, some post entry points. One for verification when we send two images to the server, and server extracts face templates and compares them to define if there are two different persons or just one person. And also he'll have some identify post entry point which gets image and extracts face template and make search in database. So let's take a look at verify uh, entry point and how we can use it. Here we can see some very basic, maybe even poor Python code, which just get two images with hard-coded paths. In this case, we want to match two photos. One of them is just photo of Sidmare, and another is photo of Deepfake seed. So we can just take a look one more time at them. Here is Deepfake seed, and here is real seed. Okay, so it's pretty basic Python post request. Let's also try to run it. Uh, okay, so we need just to um, verify. Oh, oh yes, yeah. I need to use some virtual environment here. Uh, 1 second. Okay, and now let's one more time. So, yes, basically What's happened? We uh, um, we run this code. It's send our images to localhost/verification, where our Go microservice gets two images, extract templates, compare them, and send us results. As we can uh, see here, they are quite similar. We have score around 0.97 and maximum similar score is 1. So this is a quite basic example how to use Face SDK inside Go microservices. Okay, uh, so that's all for today. I'm talking about all the major features of Face SDK that appeared this summer. If you found this video interesting and you're considering how to integrate face recognition into your business, just visit our website and fill the contact form. Thank you for watching.